All right, so we started out in the last unit just looking at unhybridized sets of orbitals, okay? So here's the unhybridized s orbital. We did that model yesterday again, and we did all these models yesterday again as well. What we're going to do is take all this stuff that we learned yesterday, and from this, we looked at how the orbitals combine to make these bonds. We're going to actually build molecules with those bonds. So, if you're on Team SP3, raise your hand over there for Team SP3. Okay? All right, all you guys, you're going to be building models in the SP3 hybridization. Okay? So, Reese, when you get your team together, you need to assign one of these molecules to each person on your team. Okay? My recommendation is the captain doesn't actually assign themselves a model. They supervise all the models. So they're helping everybody. Okay? The captain's also responsible for making sure that nobody is involved in horseplay and everybody is working. If somebody gets finished, the captain needs to make sure they're helping somebody else if they need to until everybody's done. Got it?
Yes.
All right. So we talked about yesterday how all four of these valence level orbitals hybridize. They change their shape and energy into four hybrid orbitals. And those hybrid orbitals then can overlap, can become one combined orbital, okay, and make a bond. When you share electrons, you do it in an orbital from each atom, and that shared orbital becomes a bond like this right here. So when they join together, they become a bond. Okay? So this is an Fe molecule. All right? So let's see, this is sp3. So Reese, this is one of the molecules one of your team is going to make. Okay? So this is the shared orbital that becomes this bond, and this is called a sigma bond. Any bond directly on a line between the two nuclei of two atoms is a sigma bond. Any bond directly on a line between the two nuclei of two atoms is a sigma bond. Any bond directly on a line between the two nuclei of two atoms is a sigma bond. It's spelled S-I-G-M-A. S-I-G-M-A.
What's the key? Nuclei.
It's any bond directly on a line between the nuclei of two atoms is a sigma bond. Okay, the symbol for sigma is kind of an O with a little swish on it. Okay, that's a sigma symbol.
An eye with one eyelash.
What now?
An eye with one eyelash.
There you go. Well, it doesn't have a pupil either.
It's a possessor.
Okay, possessed eye. There you go. All right. Please give me your full attention. Okay. So, notice that this carbon here is bonded not only to another carbon, showing the hybridized orbitals, we also bonded any of the remaining hybridized orbitals to hydrogens to make an ethane molecule. Okay? So all of these are bonds directly on a line between the nuclei of two atoms. There's 1, 2, 3, 4, 5, 6, 7 different sigma bonds in that molecule. Okay? Now the difference between this molecule and this one is carbon started out with 4 electrons and needed 4 bonds. Okay? Nitrogen starts out with 5 electrons in the valence level, so it only needs 3 bonds to have a full valence level. So it's going to have a lone pair of electrons that doesn't bond to anything. Going back over here to the sp3 hybridization, one of these hybrid orbitals has 2 electrons in it. An orbital can only have 2 electrons, so it doesn't bond with anything. So when the bonding occurs, one of the hybrid orbitals between each nitrogen shares to form a sigma bond between the 2 nitrogens. There are 3 other orbitals available for bonding, and we're going to put hydrogens on those. You don't actually draw the hydrogens. All we're doing is showing the bonds and the unbonded orbitals. Okay? So this is an orbital with a lone pair in it. Okay, it doesn't form a bond because it's already full. Now, this is another kind of molecule that comes from sp3 hybridization. This is, Reese, what's this one called? This is the one you asked to build the other day. Hydrogen peroxide, yeah. Okay? So oxygen came to this molecule with 6 electrons, which means it only needs 2 more in its valence level. So it can each oxygen can only do 2 bonds. So it's going to share a pair of electrons to form this bond. These 2 orbitals here are overlapping and forming this sigma bond. So there's a sigma bond between the oxygen and the oxygen. So there's also another sigma bond going out to this hydrogen on the ends. Again, we're not going to make models that show the actual hydrogen, only the orbitals or the bonds. But it has 2 orbitals on each oxygen with nothing but lone pairs in them. Okay? And here's our last model over here. This is a fluorine molecule. We looked at that already. Okay? And it only has 1 electron to share. It came to the molecule with 7 valence electrons. We just shared 1 to get to 8. So we know it's only going to form 1 sigma bond. And all the other orbitals that we hybridized over here have lone pairs in them. They don't bond to anything.